자, 솔직히 얘기해서 나도 honestly speaking, today's live stream, I have no idea in what direction that it should go. I just thought of it, the eccentricity that just popped up in the previous live stream, and I thought it would be more beneficial to go deeper into that notion, into that concept. Yes. Also today I searched the difference between notion and concept. To make sure that I don't get confused between those two. Yeah, also, I'm gonna say it right now. If the stream is lagging even a single little bit, please tell me anytime. Because I am scared. I have been monitoring for today's live stream, and I'm currently looking at the YouTube monitoring screen, YouTube Studio monitoring screen, and it keeps showing me that the gray circle of buffering. Yes, I know. And whenever that happens, whenever that thing appears when you're watching a single video, even less than 10 seconds, your stress meter goes spiking and you will never recover from that failure. So I really have to make sure that you guys are feeling confident and not experiencing any lag. Of course, if you're actually feeling the lagginess, you won't be able to hear anything what I'm saying. Anyway, eccentricity. Like I said, yes, we're gonna learn, so it's going to be pretty different. Okay, eccentricity mathematics. So, of course, I have prepared for today's live stream. We're not just going deep dive into the eccentricity without zero base knowledge. I actually have seen this. Before the live stream because I cannot do anything without any preparation. So for the eccentricity mathematics, there was a reason why it has to make sure the audience that doesn't get fucked up with the other eccentricity. The eccentricity parenthesis mathematics. I realized there was a word for eccentricity, and eccentricity that is not for mathematics. Okay, which was eccentricity. We'll never know. That is what it is. Yes. Google just told me, screw you. Screw you, Korean VTuber boy. Your eligibility of learning new knowledge is limited. Highly restricted is what Google just said. Yeah, so I don't believe that I don't have to exactly explain what eccentricity is, because it's a stupid idea. You guys speak English if you understand me. You will very well have higher English skills than I do. In mathematics, the eccentricity of a conic section is a non-negative real number that uniquely characterizes its shape. One can think of the eccentricity as a measure of how much the conic section deviates from being circular. In particular, the eccentricity of a circle is 0. The eccentricity of a non-circular ellipse is between 0 and 1. The eccentricity of the parabola is 1. The eccentricity of a hyperbola is greater than 1. So in the previous live stream, we've done something called the deriving the hyperbola function. And in that case, the eccentricity was greater than 1. So I know, when we... Well, in typically South Korea, especially South Korea, when we learn about mathematics, about the curves, the ellipse and parabola and hyperbola are the 3 main things. A circle is a different one. The 3 main curves that the high school taught the students. Yes, and hyperbola was the very interesting one, I must say. Any conic section can be defined as the locus of points whose distances to a point, the focus, in a line, the directrix, are in constant ratio. The ratio is called the eccentricity, commonly denoted as E. Yes, they really had to name this E. At first, looking at this picture, I would have never realized that the E was not the E that we already have known about. You know, that E, I know the numbers, I know the figures, I know the significant numbers until the second decimal. 2.71. That one. What's it called? The natural logarithm. I don't know. No one taught me how to do math in English. Yes. Okay, so that was E. That was easy. The eccentricity can be also defined in terms of the intersection of a plane and a double nap cone associated with the conic section. If the cone is oriented with its axis vertical, the eccentricity is E is equal to sine beta over sine alpha. Alpha is bigger than 0 and smaller than 90. Beta is bigger than 0, smaller than 90, where beta is the angle between the plane and the horizontal, and alpha is the angle between the cone's slant generator and the horizontal. Where beta equals 0, the plane section is circle. Where beta equals alpha, a parabola. The plane must not meet the vertex of the cone. Yes. How's the ring boy? I'm doing a little bit doozy. Is doozy a word? Doozy definition. Something outstanding or unique of its kind. Oh, that's not what I was going for. I'm feeling a little bit sleepy. Yes. I'm feeling a little bit sleepy because I woke up like 16 minutes ago. No, 30 minutes ago. Because I decided to take a nap before the live stream actually going on. Yeah. So I'm actually doing this live stream with my actual half of my capability. Other than that, I'm feeling good, thank you. So, doozy was not a thing. This is... Am I supposed to show you guys this? Anyway. So, there is a reason why I searched for eccentricity. Eccentricity on the... stop showing me this one. The eccentricity. And go into image section. Yes, there is always at least one photo of this one right here. Yeah, and I was wondering, like, this is about the curves, the 2D curves. Why there is some random, suddenly giant ass 2 cones appearing when I search eccentricity on Google. And that was the reason why the eccentricity is associated with the cone, like this. Yes. Imagine. Okay, hourglass. Yes, like this. Now, I believe you have an hourglass in your home right now. Prepare that right now. This is the order. So now you have an hourglass. Oh my god, hourglass. Okay, now you have an hourglass, and now you will also prepare the comically indecisive outer world's dimension plane that cuts any object and any concept, any material seamless without any friction and needs zero force to go through it. So you're also gonna prepare that, and you're gonna go slice through the hourglass. Yes, you're gonna like this. Okay, this image says it all. You start from here. You slide that. I'm just gonna say the Shasha paper. No, that sounds too childish. I'm just gonna say paper. Okay, so you're gonna slide the paper, slides through the hourglass, and this section, this cross section will look like circle. And when you try to tilt the paper, it will go from ellipse to parabola to a hyperbola. That was very easy, isn't it? That's very easy. Okay. So that was why this image keep popping up in the Google search results. Okay, the eccentricity, the linear eccentricity of an ellipse or hyperbola, denoted C of sometimes F or E, is the distance between its center and either of its two foci. Yes, I was wondering after the live stream, what the fuck this is where pronunciation go? Of course, it wasn't a foci, it was foci, it was foci. The eccentricity can be defined as the ratio of the linear eccentricity to the semi-major axis, A, that is, E is equals to C over A. Lacking a center, the linear eccentricity for parabolas is not defined. Okay, did I erase? Okay, here we go. So, at first I didn't know what does this mean, the linear eccentricity. But there's an eccentricity, E, right here. And there's also a different eccentricity, the linear eccentricity. But as you can see, the original eccentricity right here, it is FP over PP. Yeah. PP prime. More like it. So the linear eccentricity, when I first saw that term, I thought, oh, it seems like this linear eccentricity term also represents the ratio of two distances, of two values. But no, the linear eccentricity is just a distance. Yes, it represents a distance, and that's it, not a ratio. As far as I know, if I have to just gain the information about the linear eccentricity from this Wikipedia, that it's just, I see, the linear eccentricity is the distance. I see, my mind is blown. Yeah, if I'm saying something stupid or wrong, and you have the equivalent knowledge of 120 years of mathematics, please feel free to correct me in any way. Okay. The distance between center and then either side. Let's see. things right here is a little bit spoiler, which you guys probably not care anything at all. So okay. So the hyperbola. We started off with the hyperbola last time. Linear eccentricity. Linear eccentricity, the distance between the center and the either focus. So it's this one. C, you see this? Yeah, you can see this. Okay. So this is C, which is linear eccentricity. And the A was, what do you call it? Semi-major axis. Okay. Is right here. Between the center and this point. The distance between those 2 points. So the linear eccentricity was the semi-major axis. No, the linear eccentricity over a semi-major axis, which is equal to C over A. That was so fucking hard. Okay, C over A. Am I doing this correctly? C over A. Yeah. And I must say, it's kind of confusing at first time, and it's still confusing as it is because the eccentricity definition. I don't know if this is going to be considered as definition of eccentricity, but considering from this one, the ratio of between the distance, the 2 distances, yes, the FP, which refers to the distance between the focal point and the 1 point on the curve, and the PP prime refers to from the this one. Yes, okay. And I try to project in this scenario into here. Yeah. Then you'll probably think then the eccentricity might be the ratio between these distances. Yeah, I was looking for a better image that shows my my point, but it's okay. This will do. So let's say this is A, B, C. You know what? I can actually do this with my own self right here. Yes. How can I just not use this very beautiful Krita software? Okay. So. Okay. Huh? Focal point right here is the center, and this is, yes, A, B, C. Okay. Oh, you know what? I can actually do this. So, this is the hyperbola. This is the one focal point. Obviously, the other one is right here, but I'm just gonna not show that right now. But it's a focal point, the center, and this is where the curve meets the x-axis. Yeah, so I'm gonna name the focal point right here. So it's P, and according to the picture that we have just seen, you know what, I'm gonna... Did I download this photo? Yeah, I think I... So, yeah, according to this diagram right here, then this dot needs to be the P prime. You see, this dot needs to be the P prime. Then the eccentricity that we can say is the PP prime and FP. Also, this is a really genuine question. Is saying PP childish and juvenile? Or is it a mature adult joke? Yeah. What I'm saying is PP is equivalent to Cocomelon or Rick and Morty. As it always keeps bugging me out. Yes, I know there's a lot of certain adults, not only kids, a lot of adults also use the word PP. Or I don't know, maybe they're actually not adults, they claim to be adults and actually have the juvenile mindset. But I believe they were technically adults. Their age was adults, and they use word PP. And you guys can definitely agree, a lot of kids and adolescents, adolescents, they don't usually use that much, I think. What am I saying? Oh, well, I have no idea in what age group uses the word PP the most. But I was always curious about if this word PP is going to be considered as the a word that if you say it in the meetings where the adults were right there, and haha, what a great joke! Oh my god, you really made my ass laugh go off, something like that. Yes. Would it derive that reaction, or when you say PP in that situation, then the other adults exactly that moment, oh no, you just said the word PP. Now this is a time that we should move on in each distances. You will forever be eliminated from my friend group. Yes. It always made me wonder like that. Yeah, I know. It's just a single word. It's just a single word, and it might not worth all those time that I had wondering about, more like pondering about the ethnicity of that single word. But blending in whatever group you are is really important, and I believe everyone can agree that. Hopefully my stuttering goes away. As I'm waking up right now. I'm still a little bit sleepy, not gonna lie. Okay. Yeah, so according to this one, the eccentricity would be like this. Yes. So let's say this is B. This is A. And the total right here is C. Yeah. This is going to be A over B. And when we apply linear eccentricity right here, then it's going to be C over A, and C was okay. I'm gonna change it to D right there. D. So C, linear eccentricity, also known as F, and I believe why is also known as F is because the distance between the focal point and the distance. No, that's focal point right there. So it's because called F. Because of that's called F. I'm actually gonna take a second off right there and drink some water. Okay. Linear eccentricity is from the center crosses the focal point. Is a D. Yeah, okay, it's a D. And A is B. Right? Yeah. Yeah. So this is what makes me get confused. How? That is not equal. That is not the same. The linear eccentricity of an ellipse or hyperbola denotes C something. This distance between its center and either of its two foci. Distance between its center and either of its two foci. Okay, and the eccentricity can be defined as the ratio of the linear eccentricity to the semi-major axis A, that is, E equals C over A. Lacking a center, the linear eccentricity, yeah, okay. Parabola can be treated as an ellipse, or hyperbola with one focal point at infinity. I'm gonna pass this section for now, and I'm eventually gonna come back. Maybe I'm missing something very crucial. We'll eventually resolve the confusion. Yeah, that is what we're gonna do today. That's exactly what's written on the title. Okay, alternative names. The eccentricity is sometimes called the first eccentricity to distinguish it from the second eccentricity and third eccentricity defined for ellipsis. Yes, seems like one eccentricity wasn't enough. The eccentricity is also sometimes called the numerical eccentricity. In the case of ellipses and hyperbolas, the linear eccentricity is sometimes called the half-focal separation. Half-focal separation? Half-focal separation. Yeah, so actually I read this part before the live stream, and I'm not gonna read it. This because I'm not saying it's not helpful, but it makes more confusing. Yeah. Oh. Yeah, well, you can read it if you want. Values. Standard form. Conic section. Yeah, we all know this. An ellipse. Okay. Parabola. We're also gonna do deriving this one later. Maybe today. Yeah, if it's not that the crazy like last time we did the hyperbola, then we can do it today. Eccentricity is E. I mean 1, and linear eccentricity is undefined, like we have seen. The hyperbola. Yeah, okay. Can I download this image? No, but I can take a screenshot. Yeah. Oh my god. Okay. Just look at that for a few seconds. Yes, I'll be back in a GIF. Oh. Wait, is GIF also a word? GIF definition. Jiffy. Yes, I knew there was a word something GIF something. Yes. Oh. Make it a bigger a little bit. Circle. Okay, let's start with the circle. Circle. Well, the center is also the focal point. So it's 0. The linear eccentricity. I'm just gonna say F. The linear eccentricity is 0. Man, did I bite my tongue when I was asleep? I cannot pronounce any word single correctly today. Okay, F equals 0, and let's say linear eccentricity. Semi-diameter value. Semi something. Semi-major axis. Semi-major axis. Semi-major axis A. Semi-major axis A. Is the radius of the circle? I'm just gonna say A. Okay. So the eccentricity is 0 over A, which is equal to 0. I see. Right? Yes, and linear eccentricity is 0, as we have just witnessed right here. Okay. Ellipse. Semi-diameter. Let's just... Semi-major axis, semi-major axis. Not the fucking semi-diameter. Semi-major axis. Welcome. Okay, semi-major axis from the center. And... the linear eccentricity. Linear eccentricity is this distance right here. I'm gonna name it D. Oh. Oh. Okay. I thought it was a lack of my sleep that's affecting my performance. But maybe it's a compilation. My lack of my sleep and all the thing that I had after I woken up was a 1 Snickers bar. And maybe I'm suffering from the minor malnutrition or something. The linear eccentricity from the center passes the... from the center to the focal point, which is... yeah, this is the linear eccentricity. And this is the semi-major axis. Eccentricity is linear eccentricity over the semi-major axis, which is equal to A. Yeah. But the one thing interesting is that in here, the another term, the B appears, and somehow for some reason, D is equal to no, the A is equal to the Pythagoras something. Pythagoras law? That was it called? Yeah. Okay. A squared equals to D squared plus B squared. How? Why is it like this? How does people know this? Interesting. How is this possible? Yeah. So I still haven't figured out why is it like this. How we can derive this equation from just looking at this. Yeah. So when I was learning math in middle school, not in high school, when I was learning math in middle school, someone told me that the math teachers, why the math teachers, they're really great at solving math problems and consisting like hundreds and thousands of math equations, math knowledge, and their highly experienced approach on solving the problems. And those power, those absolute skills, actually comes from the mathematical god. Yes, of course. Well, we all thought that was bullshit. But more and more, when we go deeper into the mathematics, maybe there's actually something called mathematical god. I'm not gonna lie, I'm actually kind of atheist. I don't actually want to put like what kind of side I am in right now. Anyway, of course I thought there was no such thing as a mathematical god. It doesn't make any sense. Just they worked hard. They solved a lot of math problems. That's what made them to get their job as a mathematical teacher. And that's why how they're so great at doing maths. And it's just for us, in our perspective, and they're really great at math. But in reality, it's more like a basic terms. Yes, it doesn't require like supernatural power of the mathematical capability to understand the multiplication or division. That was it. But you know, there are some certain maths that has more symbols than numbers. And that could be quite convincing. That could be quite convincing if you say there's a god of mathematics. Okay. You know, I get certain anxiety whenever I see these symbols on math. Yes, I still haven't figured out what these two actually are. I know they two differ from each occasion exactly right here. Eventually right here. Especially this E. I first originally thought it was 2.71. Anyway. Center. Linear eccentricity. Linear eccentricity is the distance to the focal foci right here. And the eccentricity, no, the semi-major axis is right here. Yeah. So, okay. Eccentricity is linear eccentricity over semi-major axis, which is equal to this one. Yeah. And I believe well, it goes like this. Yeah, let me rewrite them real quick. 어떻게 표시를 해야 되지? 이렇게. But still, yeah, I don't know why the definition needs to go like this. When I learned the ellipse, parabola, and the hyperbola, I didn't start off from the eccentricity. Yes, the teachers, they didn't start off teaching eccentricity to the students. They just straight up went into the A and B. And this is what the ellipse is about. This is the equation for the ellipse, and this is the equation for the hyperbola. Yeah. Oh, I thought that the process how they derive the ellipse, parabola, and hyperbola equations was originated from the A and B. They originated from the A and B. But it seems like it wasn't like that. A and B were originated from the eccentricity. Okay, hold on. Yeah, A and B were originated from the eccentricity. And I have no fucking clue where the A and B came from. Yes. Okay. Parabola. Oh. Yeah. That's only one focal point. Maybe the reason why A and B is something like this. The relation between the A and B and the linear eccentricity. Maybe I can derive that just by looking at the diagram. Just like showing exactly as it is. Maybe I'm stupid. I won't be able to understand. Anyway, so linear eccentricity. This one is A. Yeah. You know, I'm gonna just type in F right here. Okay. It's linear eccentricity. Hold on, is this the center? From the center, from the focal point. I'm just getting confused right here. Hold on a second. What is the... Did I miss something right here? Lacking a center. Yeah, okay. Parabola doesn't have a center. Lacking a center, the linear eccentricity of parabolas is not determined. Lacking a center, the linear eccentricity of parabolas is not defined. A parabola can be treated as a limiting case of an ellipse or hyperbola with one focal point at infinity. Focal point. One focal point at infinity. I see. Maybe this diagram will be helpful. This one, yes. Thankfully, they added something into Wikipedia page that is very helpful for the Generation Z brain cells. So, okay. What are we looking for? Center goes boom, and yeah. There's also a site. That's interesting. Eccentricity. Okay, what site was it? I believe it was this one. Math is fun. Yes. So, look at this. This. Oh my god. Not gonna lie, I just felt a very critical moment of my voice giving up right now. This doesn't make sense. I have never smoked a single time, and I work out regularly. I will be raging at my deathbed if I somehow die earlier than chain smokers. Eccentricity. From the ellipse. Okay. I just want to imagine this way. So the circle is closed. Yes, it's a closed curve. And when the one focal point leaves a partner, I was about to make like your dad did when he bought to go off to buy a milk. Yes, but I decided not to make that joke. So anyway, when the one focal point leaves his partner and goes further beyond like that, and it doesn't come back, it passed waypoint of return, so it doesn't come back, the curve doesn't close, and when the eccentricity increases even further, it becomes hyperbola. Yes, then it means another partner comes in from the different side. Wow, what a crazy explanation and truth behind the hyperbolas. It's just mind-boggling. I cannot recover from this explanation. Okay, anyway. So, from the ellipse, from the parabola to a frick. Okay, from the ellipse, to parabola. Yeah, probably because it's fixed width, it doesn't show on the diagram. I see. Okay. That's what it is. Ellipse. Ellipse. The parabola. The hyperbola. For a parabola, the eccentricity is 1. Parabola, the eccentricity is 1. So, my guess is that the reason why the eccentricity is 1 in this circumstance is because there's infinity is involved. Right? The infinity over infinity is 1. Yeah. Okay, so the center is unsure. It could be here or it could be here because it's a right exact moment between the ellipse and hyperbola. A hyperbola, this center will be here, and if it's ellipse, the center will be here. Yeah. Either way, they're both infinite. They're in both infinite. Yeah. Okay, so their centers are both infinite cases. And according to the definition of linear eccentricity and semi-major axis, then this is infinite, and the semi-major axis is also infinite. Yeah. But I want to point it that way, that the it's more like this, right? Yeah. You just can't simply just write the infinite over infinite and is equal to 1. Yeah, when you write this in front of math teachers in high school, there's like 70% of chance that you'll get hit by a ruler. Well, gladly that doesn't happen these days, but have you ever beaten with the wooden stick that used in construction site? I actually have, and I still remember the exact scenario, exact weapon, and exact person who did that. It's forever scarred inside my brain, and I'm so glad that they don't use the physical weapons that seem to be existing in Elden Ring to punish students. Yeah. Well, it's a kind of a double-edged sword, I must say. The good side is that the teachers, the instructors, they don't harm the students. They don't harm. It's actually very obvious. Very fucking obvious. They don't hurt students. And students can actually remain their creative thought and their hope and their motive to study. Yes, but at the same time, it also encourages the bad students, the bullies, or just some kind of trolls that want to mess up teachers' day. Yes. The reason why I use the term encourage is because hitting students is really extreme, really extreme. Well, what's that word? Extreme solution. Yeah, extreme solution to fix one student's mind or posture or their behavior. Yes, but mostly based on the fear and humiliation, the fear of getting hurt, because it's fucking painful. And believe me, I know how painful that is. Fear of pain and humiliation is that you usually get punished or hurt by instructors in front of the other students. Yes. Normally, when you get punished, normally when you get physically punished from the teachers, you get hit in front of the other fellow classmates, and that's where the humiliation comes from, and the unsupportive. Yes. Are you a professor? No. Well, I'm not a professor, but surprisingly, believe it or not, I was once called the professor when I was an elementary or elementary school student. Yes, it was my nickname. I have to admit, I kinda forced my nickname to be a professor at then. It's kinda cringe, But you know, elementary school students, am I right? So, anyway. The why I'm saying the unsupportive part comes from the parents or the other fellow teachers, because I'm not saying that they're bad because thinking it that way, because at that time it was like a few decades ago, and at that time, fucking hitting the teachers, fucking hitting the students and kids wasn't normal back then. You know what that meme, the hitting kids with slipper? No, hitting kids with the metal bar was considered normal back then. You know, a definitive integration. Tomorrow is my test. Can you please explain something? Why does keep people coming to my stream expecting to help with their test? No, if you want to get a good score on your test, close this live stream and look deeper into your textbook. That's my best advice. Yes, definitive integration. Well, I know integration. Of course I know integration, but what is definitive? Who are you? Yeah, so, where was I? Yeah, okay. Okay, you know what? Thanks to you, I forgot where did I left off. Congratulations. Well, what was this? Oh yes, I was talking about hitting students. Yes, I'm talking about. I believe there's a specific term referring to hitting students, punishing them. Okay. Look, I'm not your professor. I am not your instructor. Just search it up on Wikipedia like I'm doing right now. Yes. Okay, so since you're talking about the definitive... The fuck is what? Definitive integration, I believe you are a university student, and you probably know that Wikipedia is your friend. Yes, but don't... Oh, thank you for the subscription though. Thank you so much. Yes, but don't actually cite this Wikipedia in your article or lecture. Yeah. The professors or the TAs mentioning that if you write the Wikipedia as a source of citation, you'll get an instant F. Oh, they're mostly joking. Yes, but it's not 100% they're joking. They're 99% joking that you'll get fucked up if you write the Wikipedia in the citation page. As you know, you probably know more than I do. I think ChatGPT is better than Wikipedia. You are actually right. Yes. You know what? You are right. Wikipedia, well, in my generation, Wikipedia was the GOAT. But now the technology has got involved so greatly, and everybody uses AI nowadays. ChatGPT, you're actually right. Yeah. The only worst thing using ChatGPT I can say is that you cannot even write that in citation though. Yeah, this. ChatGPT. And okay, you know what? I know there was some person who got into a trouble using ChatGPT. I believe it's a worldwide a problem that the university, people needs to solve. You have a lizard in your room. It is not a sentence I expected to have us to have a. It's not expect. You know what? Never mind. Yes, my brain is not functioning correctly at this moment. Okay, so in writing reports, and writing the reviews, writing an essay, whatever that is, whenever it comes to writing like several sentences on your page, yeah. I've seen students. Yes, in my later days of my university, I've seen younger students. Why I'm saying that my age gap is too big from the younger student. Anyway, the first years or sophomores, they're using ChatGPT. Yes, well, of course, I have seen professors and TAs also using ChatGPT too, but when it comes to writing a huge essay, using ChatGPT can get you into a really big problem. And I believe you also know that one student got into a trouble using ChatGPT. And the funny thing is that student never confessed that that student used the ChatGPT, nor the professor and the TAs like cave digging into the pattern of the nor the professors and TA hacked into the student's account and they discovered that student used ChatGPT. No, it didn't happen like that. They actually know that their essay was written in ChatGPT because it looked like it was written in ChatGPT. Yes. So what I'm saying is that ChatGPT is so reliable. So many students, so many people use that. ChatGPT somehow got a like low-key sentient character in writing an essay. So therefore, whenever professors or TAs receive their essays from their students, they realize it's written from the AI. Because they have seen so much cases on the AI assisted written essays. They recognize the pattern. And they definitely know the obvious patterns of the ChatGPT, how it writes the essays. And that student, as far as I know, got an F. And as far as I know, yeah. I don't think that student got expelled, but that student got an F. Okay. We should humanize the essay from another AI tool so that we don't get caught. I don't know about that, man. I don't know about that. Yes. Although my inner conscious is yelling me, screaming at me inside my brain. That's actually a good idea. So we don't get caught and we can flawlessly pass the university and get this sweet certificate. But at the same time, At the same time, no, we should not, yes. You go to university to study and not cheat. I believe everyone can agree to that. Yes. Why go to university in the first place? Yeah. If it's only just for because the one single certificate paper, that's kind of sad. Going to university only to get the one single certificate paper. But when I was going in the university, when I was a university student, and in the late years, my thought switched from, oh, I'm just gonna do whatever they throw me at my table, and even though it's really struggling, I'm just gonna do it. I want to get my grade really good. I want to get my good scores and such as that. But as the time passed, and when I was in the late year, yeah, when I was in late year in the university, in the late years, my thoughts switched to, I'm gonna graduate this school, at least some single fucking knowledge attached to my brain. Because for some miracle reasons, whatever thing I learned in university, it just didn't stick inside my brain. Do you guys ever had that feeling that when you learn something and it just fades away as soon as the test is over? I always had that kind of feeling. So yeah, that was the motivation for me to finally change my mindset and actually try to remember something what I learned in university. And also, okay, I just remember what my stream title was. We got a huge sidetrack right there. So about the eccentricity. Okay, alright, I was about to search a term that represents hitting a student, but you know what, I sidetracked too much, and maybe later I talk about that. Okay. Wait, don't tell me that you guys have been seeing black screen the whole time. Anyway, so I like to put it this way. Yes, infinite over infinite is not actually one, not this one. Yeah. I believe that in this scenario, the parabola, the eccentricity sums up to the 1, and the reason behind that is because they go to infinity in the same speed. Yes. Okay. So that was the eccentricity in here. Here's the general form. When the conic section is given in the general quadratic form, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, when the conic section is given in the general quadratic form. Yes, and I believe that they wrote it this way because, well, if we rearrange these equations, then we can get back into this one, is what I can glean from. The following formula gives the eccentricity E if the conic section is not parabola, which has eccentricity equal to 1. Not a degenerate hyperbola or degenerate ellipse, and not an imaginary ellipse. Imaginary ellipse, as if it couldn't get any harder. Okay. Oh. Okay, I see why this is. Okay. When eta is 1, if the determinant of the 3x3 matrix is negative or n eta is minus 1, if that determinant is positive. Am I having a stroke when eta is 1 if the determinant when eta is 1 if the determinant of these 3x3 matrix where eta is 1? Hey, maybe I really was having a stroke. Where eta is 1 if the determinant of the 3x3 matrix is negative, or eta is minus 1 if the determinant is positive. Okay, let's see. And when I say let's see, we're actually gonna see how that does make sense. Okay. There's a reason why degenerate hyperbola or degenerate ellipse has a blue hyperlink right here. Maybe it leads to something else that I usually know. Maybe we'll click into the later, but for now. Not a parabola, so AX is not a hyperbola, not a hyperbola. But it's not a hyperbola. And the eccentricity, the definition is root 1 minus. And I would really love to change this form into, let's say, to an ellipse. Then it's going to be like that. How am I supposed to do that? 가능한 건가 이게? 어. Okay. Okay. What is it? Hold on. A general hyperbola or oh my god. Okay. Okay. And wait a second. Yeah, this was the eccentricity of the ellipse. I still have no clue how can this go from here? I mean, how can from this go to here? Following formula gives the eccentricity of the cutting section in a parabola. Okay. But why? But why? Kinda like this. Probably should be our channel's motto. 1 minus b squared over a squared. How and why? Okay, I think this applies. When it's okay. Yeah. Okay, I'm gonna do something called a very crazy move. So, not all the ellipse is really kind and only exists on the center plane. Originated from the origin. Yeah. Like this. What I'm saying is that this is the origin right here, and ellipse can be like here. Yeah, not all ellipse exists in here. It's sometimes here, sometimes here, sometimes here, and sometimes here, and it makes a very huge smiley face. So, ellipse can be existing in somewhere else besides the origin of the grid. And we can do that by substituting the x and y coordinates into something like this. Like, let's say I'm gonna do something like this. Yeah, okay. Then we will get the values of the b and d and e. Now we won't get the values of b. How the hell we get the value? It doesn't make sense. Yes, this one doesn't make sense. We will never get the values of b. That's actually impossible. Ah. Why though? Seriously, why though? Maybe this is a wrong approach. Maybe this is not a correct approach. The eccentric of the ellipse was 1 minus b squared over a squared. Yeah. And oh god. I actually planned for today's live stream to be like 2 hours long. And I was really trying to keep the promise because I really didn't intend to stream long for this type of live stream. And that's basically the only reason. Oh, but why? Why? Why does it go like that? Okay. The ellipse is here. The ellipse is here. Why? The frustrating part about this is that this is not even a curve. This is not even about a curve. This is about how the fuck this goes into this. Semi-major axis. Linear eccentricity. Semi-major axis and linear eccentricity. Semi-major axis. Linear eccentricity. Semi-major axis. Linear eccentricity. Okay. I'm gonna say that's this is an ellipse in this formation. Then okay. I gotta keep remind me of myself that I am smart. I'm not stupid. Even though it's quite obvious that it doesn't seem smart. I'm fooling my own brain. I fool my own brain. To make it believe that it is very intelligent behavior. Oh. Okay. This one times b squared plus e plus 2 a squared equals to a squared b squared b squared. I can do this. I can do this. Okay. The center is minus alpha. Minus alpha. Minus beta. I don't think we need explanation for this. Like minus alpha minus beta. And it's alpha. The no, y coordinate, when the y coordinates is minus beta. Okay, center. When the y coordinate is minus beta, then the let me just my best hope is that I probably don't need this. Minus beta. When the y is equal minus beta. then the x is wait a minute. Yeah, x is a plus alpha. Well, wait a minute. Oh, okay. And the y is minus beta, then the x is a plus alpha. Alpha plus a. X is alpha plus a. Or alpha minus a. Oh, wait. Okay, minus beta. Minus alpha minus beta. Then well, of course, it can be on both sides. It can be on both sides, like in this one and this one. But I'm just gonna write in this one. Okay. And when the focal point, okay, b alpha, when the x is minus alpha, then the y value needs to be minus beta plus b. Yeah. And semi-major axis, the linear eccentricity value is going to be root of, oh my god. 아우, 뭐가 이상한데 이거? 아, 짜. This is kind of very weird. I keep having that Nokia Arabic ringtone keep playing inside my brain non-stop. Probably this is a good time to call it a day. Hey, you know, this idea was a bad idea. It's a stupid idea. 뭐야 이거? A is equal to and B is 0, just plain 0. Okay, I admit it, I have no idea how the constant value of xy can be derived from the equations of the ellipse and hyperbola. Yeah, I guess that's something that I missed. I guess that's something that I missed, or something that I haven't informed yet. I think that's a different part of the thing that we're doing today, not the part of curves. I think that's something else. But not now. Okay, C is A square. D is 2 alpha B square. E is 2 beta A square. And F is... okay, hold on. Yeah, okay, F is... alpha square B square plus beta square A square minus A square B square minus A square B square. Holy shit. Okay. So very intriguing. According to this, I could just type the eccentricity is substitute the B square and A square into A and C. And the eccentricity is just basically 1 minus A over C and apply root. Oh my god, hold on, wait a minute. You guys have no idea what I have just experienced. I believe you have already at least once said about the term that my bladder is going to burst. Yes, but thankfully, bladders don't burst like a balloon. They just keep expand until the pressure cannot handle it, and you just release it regardless of your intentions. That's what's going to happen, and I was like 0.7 seconds away from that happening. Yes. There was no need for muscle contraction or relaxation. It was just spontaneous release. A crazy experience. And I don't want to. What was that? I don't want to elaborate in detail about what just happened. Anyway, yeah. So I could have just wrote into this 1 minus a over c, apply the root in total. Yeah, but the Wikipedia says I am wrong. This is quite very different from what I wrote. Why? I genuinely cannot tell why. Like, seriously, why? Angular eccentricity. Okay. There's still a lot of stuff. There's a lot of stuff that I go through. Maybe the answer is here. I don't think so. But at least I can guess. At least I think I know what the determinant of this is. Yeah. I think I know how to calculate the determinant of the matrix. I know how to calculate the determinant. The matrix that is over 3 dimensions long. Okay, first I'm gonna tag this I don't know right here for future revisits, and determinant. Determinant of that A. E over 2. So I believe it was something like this. Okay. No, I'm gonna explain it. Okay. The only problem is that I forgot the exact word that represents the determinant of only in this area. Determinant eliminating specific rows and columns. 여집합이구나 그럼. 여행별. determinant of 3y. Ah, okay. You guys cannot see what I'm doing right now, but I'm actually looking at the... Oh god. The Google page. The Google page. Matrix. See. So now I remember. Okay, this one. Okay. This is a classic. It's a classic. I'm not gonna prove why it has to be like this. Okay. A. Okay, 1 times A times determinant of this area. Okay. And minus 1 time. I'm gonna type plus minus e over 2 into this section of the determinant. And finally, plus 1 time that are smaller. Okay, then it turns into EF minus square root. Oh, this isn't any easier. Okay, E over 2. Or plus okay, E over 4 minus C E over 2. Okay. I don't want to solve all of these, and I don't think it's solvable. But let's do this. Okay, ACF minus What do you know? Okay. So this is the determinant of that matrix. When eta is 1, if the where eta is 1 if the determinant of the 3 by 3 matrix is negative, or eta is -1 if the determinant is positive. So what this thing is saying is that if this shit right here is negative, then the eta is 1. But if it's positive, then the eta is -1. Okay, I see that. I can definitely see that. My guess that where the b value comes from is when it's rotating the curve. Yeah, not like in right angle rotation. I'm talking about like this shit right here. Yes, 2 focal points right here. Between S and body. This is you. Congratulations. Anyway, I think that's the reason. I think that's the only case where I can find the values of B. My assumption is that it's just a mere speculation. Okay. Where did this even come from, though? Not gonna lie, I thought that this is going to be, well, difficult. Today's live stream is going to be a little bit difficult, but not this severely Einstein level difficult. I keep bumping into so many obstacles right here. The problem is I keep bumping into it. I don't know how to break through the rock. Smashing your head into an obstacle often solves your problem, but it's like probability based. Yes, it often breaks through your obstacle, but sometimes it breaks through your skull. I think everyone can agree to that. Ellipses. The eccentricity of an ellipse is strictly less than 1. And circles, which have eccentricity 0, are counted as ellipses. The eccentricity of an ellipse is greater than or equal to 0. If circles are given a special category and are excluded from the category of ellipses, then the eccentricity of an ellipse is strictly greater than 0. What? When circles are 0 circles are given a special category and are excluded from the category of ellipses. Eccentricity of an ellipse. For any ellipse, let A be the length of its semi-major axis and B the length of its semi-minor axis. In the coordinate system, with origin at the ellipse's center and x-axis aligned with the major axis, points on the ellipse satisfy the equation. For any ellipse, let A be the length of its major axis for a system with the origin at the ellipse's center and x-axis aligned with the major axis. points on the ellipse satisfy the equation. Yeah, that's what we got. That's what I got. I didn't show that on stream. With foci at coordinates plus minus c, comma 0 for c equals the root of a squared minus b squared. Name. First eccentricity symbol is e in terms of a and b. Wait, we define a number of related additional concepts only for ellipses. First, second, or third. Hey, first, second, or third. First eccentricity in terms of a and b. Root 1 minus b squared over a squared in terms of e is e. The second eccentricity is this is I see. The third eccentricity is this one. And I'm hopefully no, they don't elaborate about the m. Just m. That's it. Okay. Root a squared minus b squared over root a squared plus b squared equals this one. Angular eccentricity. Inverse cosine of e over a equals to inverse sine of e. Angular eccentricity is one of many parameters which arise in the study of the ellipse or ellipsoid. It is denoted here by alpha. It may be defined in terms of the eccentricity e, or the aspect ratio b over a, the ratio of the semi-minor axis and the semi-major axis. Alpha is this. Okay. Okay, I think I know what it means. Alpha is this one, a is this one, this one. Sine alpha. Inverse sine of eccentricity. Inverse cosine of e over a. Okay. Inverse cosine of e over a. Let's see. Cosine alpha is b over a. Inverse cosine of b over a is alpha. Okay, angular eccentricity. I see what it is. Angular eccentricity is not currently used in English language publications on mathematics, geodesy, or map projections, but it does appear in older literature. It's not currently used in English language publications on mathematics, but it does appear in older literature. Alright. Any non-dimensional parameter of the ellipse may be expressed in terms of the angular eccentricity. Such expressions are listed in the following table after the conventional definitions. In terms of the semi-axis, the notations for these parameters varies. Here we follow RAP. Okay. First eccentricity is this one. Second eccentricity is this one. Third eccentricity is and first flattening. Second flattening. Third flattening. I was kind of hoping that they would explain more about why it's called differently. What makes it called the first, and what makes it named second, and what makes it has a name third. I know I keep being salty about anything and being too paranoid sometimes, but I think I kinda understand why the professors told me not to use Wikipedia as a citation. Yes, I was kinda craving more knowledge and intelligence. But I'm afraid I cannot find any avoidable way to say that it kind of fails to educate in the depths of my requires. Other formulae for the eccentricity of an ellipse. Maybe I missed something here. Okay. Numerical eccentricity. Other formulae for the eccentricity of an ellipse. The eccentricity of an ellipse was simply the ratio of the linear eccentricity c, distance between the center of the ellipse and each focus. Center of the ellipse. And each focus. The length of the semi-major axis A. The eccentricity is also the ratio of the semi-major axis A to the distance d from the center to the directrix. Center to the directrix. What is directrix? directrix가 주선 그거였나? The eccentricity can be expressed in terms of flattening. F defined as F. 1 minus B. 1 minus B over A for semi-major axis A and semi-minor axis B. Jesus. Directrix. Yeah, I think the directrix refers to this line here. Conventional definition of eccentricity? I don't know. Directrix. Semi-major axis. Semi-major axis. Yeah, it makes sense. Okay. Where can I find the directrix though? You know, what is even directrix in the first place? Okay. Directrix. In mathematics, directrix is a curve associated with the progress generating a geometric object, which has curve associated with the process generating proof. Oh, okay. This might be something that I'll be delving deeper into the next stream. Anyway, what is this? Each of the two lines parallel to the minor axis and at a distance of d equals excuse me, a square over c equals a over c from it. It's called the directrix of the ellipse. See diagram. Yeah, okay. So this is, in my perspective, follows the definition of the conventional definition of eccentric. This is the directrix line. L1 and L2. And the distance d refers to a square over c. For the arbitrary point P of the ellipse, the quotient of the distance to one focus and the corresponding directrix, the diagram, is equal to the eccentricity. Yeah. PF1 over PL1 equal to PF2 over PL2 is equal to eccentricity just equal to C over A. Yeah. This is a linear eccentricity and this is the semi-major axis. The proof for the pair F1, L1 follows that from the fact EF1 square is equal to x minus c square plus y square. Oh, okay. X minus c. And EL1 square is equal to this is Pythagoras method, by the way. PL1 square is equal to x minus a square over c. Where? Huh? I don't get it. Anyway, and y squared equals b squared minus b squared. Okay, this is the just different formula of the ellipse. See that? Let's try the equation EF1 square minus E square over A square. E1 square equals 0. 보자. The second case is proven analogously. Okay, I don't understand. I don't understand why the distance between. Oh, what the fuck is this? Okay, the distance between. Oh, look at this. Okay, okay. This is huge. This is huge. I think I was correct. I think I was correct. Yes, the rotation of these shapes leads to the existence of the value b right here. And I think I have to continue this in the next time. This is way more descriptive and well, that's all I can say. Very descriptive than I had imagined. And I don't think I can handle all of these information in one stream. Yes. I'm not gonna lie, my plan was just to go through this one Wikipedia page and just yap about something. Whatever the thing comes to my mind. But this actually has so much value inside it. And I can see that. I can see that right here. Okay. But I kind of want to see why that has to be a squared over c. Was it c squared over a? I don't know. Okay. Wait. Yeah, maths can be very beautiful, but it is only beautiful in beautiful people's hand. Yes, the only thing that I can see from the math is quite distant from the beauty. This is so mesmerizing. I like it. An ellipse in red as a spherical case of a hypotrochoid. Have I ever mentioned that in my scenario, in my case, numbers are more easier to read than English words. Yes, it doesn't have to be any certain language. Korean, English, any language. Compared to that, numbers and equations are more comprehensible, and it's no joke. And it doesn't mean that I didn't read too much. I didn't read many books when I was young. No, it's quite contrast. I read so many books when I was young. It doesn't have to do with the amount of books what you read. I think I was just born in this way. So anyway, yeah, we know what the directrix is now. The directrix. The eccentricity can be expressed in terms of flattening, defined as f equals 1 minus b over a for semi-major axis a and semi-minor axis b. Okay, so this is flattening. Yeah. Flattening is a measure of the compression of a circle or sphere along a diameter to form an ellipse or an ellipsoid of revolution, spheroid, respectively. Other terms used are ellipticity or oblateness. The usual notation for flattening is f, and its definition in terms of the semi-axis. You know what? I really want to press the button to close the stream, but I cannot wrap it up with loose end. And b of the resulting ellipse or ellipsoid is a minus b over a. Okay, the compression factor is b over a in each case for the ellipse. This is also its aspect ratio. Aspect ratio. Okay. I believe if I click this aspect ratio hyperlink, that it will remove me from the mathematics whirlpool. I think this will lead me to a television. Well, sorta. No, we're still in the mathematics region. I see. There are three variants of flattening, sometimes called the first flattening, as well as two other flattenings, f prime and n, each sometimes called the second flattening, sometimes only given a symbol, or sometimes called the second flattening, and third flattening respectively. In the following, A is the larger dimension, exemplified criteria, semi-major axis, whereas B is the smaller semi-minor axis. All flattenings are 0 for a circle. A equals B. First flattening, fundamental, geodetic, reference ellipsoids are specified by giving 1 over f. A second flattening, f prime, a minus b over b, rarely used. Why the fuck? Okay, third flattening, n, a minus b over a plus b, used in geodetic calculations as a small expansion parameter. I have no idea what it means. Identities. The flattenings can be related to each other. F equals 2n over 1 plus n. N equals f over 2 minus f. It's just that, yeah, I think it's just different formation. Flattenings are related to other parameters of the ellipse. For example, b over a is equal to 1 minus f, 1 minus n. I think the first, second, third, the nominating. Is nominating a proper word to use this in this scenario? The first, second, and third. I think just they're just yeah, it's just a different method of writing, of flattening. Yeah, it's just a variance of how you write it. I think that's the best explanation that I can think of. Used in geodetic calculations as small expansion parameter. Yeah, I think that's what it is. There are just some various types, and I think not all of them that I have to remember like crazily, I guess. You define the maximum and minimum radii, maximum of R and maximum radii, minimum radii as the maximum and minimum distances from either focus to the ellipse. That is, the distances from either focus to the two sides to the two ends of the major axis. Distances from the either focus to the two ends of the major axis. Then with semi-major axis A, the eccentricity is given by that thing. Are you kidding me? Okay. R max minus R min. I see. So, R max. Where's the R max? I think it means the distance between this focal area, this focal point, and this point right here, the distance between here, and the R min is a distance between here and here, I think. Yeah, that is why that is saying it's 2a. Okay, 2a over R max. Or R max minus R min, which equals to, hold on. Yeah, which equals to the distance between two focal points. Yeah. Which is the distance between the... Oh yeah, which is distance between the foci divided by the length of the major axis. It is also the eccentricity. Well, that's also correct. Well, because we already defined that the eccentricity of the ellipse is equal to linear eccentricity over semi-major axis, which is the linear eccentricity is half of the value of R max minus R min, and the semi-major axis, which is equals to A, obviously is a half value of 2A. But basically, it's just the same value. Okay. Hyperbolas. The eccentricity of a hyperbola can be a real number greater than 1 with no upper bound. The eccentricity of a rectangular hyperbola is root 2. The eccentricity of a hyperbola can be a real number greater than 1 with no upper bound. The eccentricity of a rectangular hyperbola is root 2. I see. Well, I think that's it. The eccentricity of a three-dimensional quadric is the eccentricity of a design section of it. For example, on a triaxial ellipsoid, the meridional eccentricity is that of the ellipse formed by a section containing both the longest and the shortest axis. Kill me. One of which will be the polar axis, and the equatorial eccentricity is the eccentricity of the ellipse formed by a section through the center perpendicular to the polar axis in the equatorial plane, but conic sections may occur on surfaces higher order to speaking. Zero to infinity. Oh. A parabola and one cubic. Parabola and one cubic circle. Ah, okay. Celestial mechanics, main article, orbital eccentricity. In celestial mechanics, for bound orbits in a spherical potential, the definition above is informally generalized. When the apocenter distance is close to the pericenter distance, the orbit is said to have low eccentricity. When they are very different, the orbit is said to be eccentric or having eccentricity near unity. The definition coincides with the mathematical definition of eccentricity for ellipses. In Keplerian, I don't know how to say that, 1 over r potential. Apocenter. Pericenter. Okay. you're watching this right now, congratulations. If you're watching this right now, congratulations. You have earned the approximately 2 hours and 40 minutes of knowledge of ellipsis. No, eccentricity. God fucking damn it. I can't even remember what I was doing for today's live stream. Anyway, I thought it was a good idea to learn the cool concept of eccentricity together, and I think I will never do it again. Yeah, I'm not saying that this sucks, this stinks, this reeks of nerd. I'm not saying like that. Yeah, I'm gonna think of something else. Yes, I'm gonna think of something else besides just reading the Wikipedia brain dead. Yeah. Okay, that's interesting. Well, this stream sucked, but at least I can say, since I now know some general concepts of eccentricity, it will be much helpful for the further streams, in the future streams. Yeah, let's just say that we sharpened our weapon. We cleaned our pistols, we cleaned our guns with oil, of course, and we sharpened our pencils. Did I say that? No, we sharpened our pencils. And now we're ready. Now we're prepared. Okay. I guess that concludes for today's live stream.